So in today's session, we are going to look at Cambridge International Examination Physics Motion question paper. So we're going to answer a few questions on motion. So let's get started. So here we go. The graph represents the motion of a train traveling between two stations. Which statement about the train is true? A. Its acceleration takes a longer time than its deceleration. Is that true? If you look at this point here, it's accelerating from this point to that point. So it's accelerating for only 100 seconds, and the deceleration starts from here to there. This is the deceleration, and this is the acceleration. So the deceleration is taking place for all that time. This is 900. 900 minus 500 is 400 seconds. So if they're saying that its acceleration takes a longer time than its deceleration, this is incorrect. Moving on to B, it travels at a constant speed for less than half of its journey time. Its total journey time is 900 seconds. When it starts from there to there, its total journey time is 900 seconds. However, they are saying that it travels at a constant speed when it is traveling at a constant speed during this period of time. That's when it's traveling at a constant speed, and they're saying that it travels at a constant speed for less than half of its journey time. If you look at the time spent while it's moving at constant speed, it moves at constant speed from 100 seconds to 500 seconds. So the total time taken here is 500 minus 100, which is 400 seconds. Is 400 seconds less than the total journey time? Yeah, it is. So this could be correct, but let's first check out the rest. It travels 2000 meters in the first 100 seconds. So in the first 100 seconds, that is when it is accelerating from 0 to 100 seconds. They're saying that it travels 2000 meters. So let's try and calculate the distance traveled in the first 100 seconds. So looking at the first 100 seconds, which is right there, the distance traveled, of course, area under a speed time graph is the distance traveled, we shall say is going to be a half times the base of this triangle, which is 100, times the height, which is 20. And so we shall end up with by 2 ones, by 2 10, that is 1000. So it travels 1000 meters, not 2000. So this is wrong. Then also D, it travels 10,000 meters at constant speed. So this is the part where it travels at constant speed. This part right there, it travels at constant speed. So we simply try to find the area of that right there. So the distance traveled at constant speed is going to be equal to the area of that portion, which is going to be 20. 20 so happens to be the length here. Let me call this my length, then let me call this my width. So that is the width is 500 minus 100, which is 400. So it's 20 times 400. This is going to become 4 times 2 is 8, then the 3 zeros. It travels 8,000 meters, so this is also wrong. So that means that our answer is B. So B is our correct answer for that. Then we have 2. A car travels 6 kilometers along a main road in 6 minutes. So 6 kilometers in 6 minutes. It then travels 2 kilometers along a minor road in 6 minutes. Okay. Which calculation of average speed for the whole journey is correct? So the calculation for average speed, we know that average speed gives us total distance, divide that by total time. And we know here that the total distance here, we have the first 6 kilometers, then 2 kilometers. So it's going to become 6 plus 2, all this is kilometers, divide that by the total time taken, which is 6 minutes plus another 6 minutes, so which is also 12 minutes. In other words, this is going to be 8 kilometers, divide that by 12 minutes. And if you look at the workings here, 8 kilometers divide by, it's supposed to be divided by, so this is out because it's multiplication, this is addition, that is also out. So we have these divisions here. So it is 8 kilometers, divide that by 12 minutes. So the answer is A. Then we have another one here, which distance time graph represents the motion of an object moving at constant speed. So moving at constant speed means that, remember, we are looking at a distance time graph, and the gradient for distance time graph means the gradient for distance time graph is what is going to give us the speed. So if the gradient is constant, it means the speed is constant, and from the distance time graphs we are seeing here, we are able to see that d is constant. The gradient of this distance time graph is constant, meaning that it is in this graph that the speed is constant. Now do not confuse this for, we can have a graph here for speed, time. Now here for speed time graph, well, and then I draw something like that, and then it moves like that. For speed time graph, we see that from, let's say, from point A here, B, C. So when it comes to speed time graph, the gradient of speed time graph is giving us acceleration. So because it's giving us acceleration, we are seeing that the gradient between B and C, the gradient is constant here. So because the gradient here is constant, it simply means that the acceleration here is constant. It means that the speed is increasing at a constant rate, or the rate of change of speed is increasing at a constant rate. So acceleration here between B and C is constant, and between A and B is now what we call constant speed. That is for a speed time graph. But here we are looking at a distance time graph. And distance time graph, the gradient of a distance time graph is going to give us the speed. So here we are looking at the gradient of the distance time graph, which is giving us speed. So here it is speed that is constant, just like the way here we said acceleration is constant. So the answer is D for that. Let's move on to the next. Number 4. The graph shows how the speed of a car changes with time. What calculation gives the distance traveled by the car in 24 seconds? So this is speed time graph. The car travels for 24 seconds. So the distance traveled means we are going to find the area under that graph. It so happens to be a triangle, so the area under that is going to give us a half times the base times height, which is going to give us a half times the base, which so happens to be 24 seconds. 24 seconds, multiply that by the height, which is 14. So you realize that from what we have here, this is 24 times 14, divide that by 2. And that is coinciding with this. The answer is C. Moving on to 5. A car takes 15 minutes to travel along a road that is 20 kilometers long. What's the average speed of the car? Average speed is given by total distance. Divide that by total time. What's the total distance? A car, we're talking about 20 kilometers. Yeah. Divide that by the total time. Now the total time is 15 minutes. However, okay, let me put it there, 15 minutes. But you realize that this is kilometers divided by minutes. Our answer is in kilometers divided by hours, kilometers per hour. This is supposed to be K. This is supposed to be K. I think my computer somehow omitted. Those are supposed to be kilometers per hour. So the answers here are all in kilometers per hour. Okay, so meaning that whereas we have 20 kilometers in the numerator, the denominator should be converted to hours. So it means this is the same as saying it's going to be 20 kilometers. Divide that by 15 minutes is a quarter of an hour. So it is a quarter of an hour. That is, so 20 divide that by a quarter is the same as 20 times 4 over 1, finding the reciprocal of that. So we end up with 80 kilometers per hour. And 80 kilometers per hour is C. That is our answer. We have question 6 here. The graph shows how the speed of a car changes with time. Between which two times is the car stationary? Of course, a car will always be stationary when its speed is 0. And that happens between x and y. So our answer here is D. Next, a man stands by a railway track. A train traveling at 40 meters per second takes 2 seconds to pass the man. What is the length of the train? So that's the train moving. It's train moving at 40 meters per second. So the speed of the train is 40 meters per second. And it takes 2 seconds to pass the man. So the entire length of the train is going to take 2 seconds. Wow. 2.0 seconds. That's the time taken. And so what is the length of the train? That is the distance it travels in those 2 seconds past this man. So what's the distance? So to calculate here, the distance we know is speed times time. We know that speed is 40. Multiply that by the time, which is 2. This is going to give us 80. So the answer is D. An airplane flies from X to town Z, stopping for 1 hour at town Y to pick up more passengers. The distances between the towns are shown in the diagrams. The total time taken between leaving X and arriving at Z is 3 hours. What is the average speed for the aeroplane in the air? Now let's look at this very closely. An airplane flies from X to town Z, stopping for 1 hour. So meaning when it's flying from X, moving to town Z, it's going to stop at Y for 1 hour. Now if it is stopping at town for 1 hour, that is time spent without moving. Okay, so it's stopping for 1 hour at town Y to pick up more passengers. The distances between the towns are shown. Yes, we can see. The total time taken between leaving X and arriving at Z is 3 hours. So it's going to spend 3 hours. But within these 3 hours, there is 1 hour inclusive in these 3 hours. The 1 hour that they're talking about where it stopped at town Y to put in more passengers. So they're telling us that what is the average speed of the aeroplane in the air? You can even see that it has been boldened. They want to find the total speed of the plane while it's moving in the air. When it stopped for 1 hour to put in more passengers, we don't put in more passengers from the air. Maybe that happens in science fiction movies, not in real life. So meaning that, well, whereas the question says that the total distance traveled from X to Z is 3 hours, yeah. However, of the 3 hours, 1 hour was spent on the ground trying to, add in more passengers. That is at town Y. So we are going to remove that 1 hour from here. So it means the total time spent in air traveling is actually 2 hours. 3 minus 1 hour, which is 2 hours. So the time here is 2 hours. Okay, what's the average speed of the aeroplane? So we have the time as 2 hours. The total distance is 3 plus 2, which is 500 kilometers. That is 300 kilometers plus 200 kilometers to give us 500 kilometers. So meaning the average speed is given by total distance, which is 500 kilometers. Divide that by total time, which is 2. And so from our answers here, and this is 2 kilometers to 2 hours. From our answer here, we are able to see that the answer is C. So next, the diagram shows the speed time graph for a train as it travels along a track, as you can see. For which part of the graph is the train speed changing at the greatest rate? So we have the speed time graph right there, and we know that the gradient for a speed time graph is acceleration. So when they ask for which part of the graph is the train's speed changing at the greatest rate, so from there we only look at the part of the graph where the gradient, or call it the slope, is steepest. Because the steeper the slope, meaning the higher the rate of change. That is what it means. So from what we can say, this is a gentle slope, this is a steep slope. So this is also a gentle slope, this is a flat. So this one is steeper. Between R and S, it is steeper. So if it is steeper, they're saying for which part of the graph is the train's speed changing at the greatest rate. So it is changing at a greatest rate between R and S, and that is C. Only that the change this time is that it is reducing at a higher rate. A small steel ball is dropped from a low balcony, ignoring air resistance. Which statement describes its motion? So as a steel ball is dropped from a balcony, it falls with constant acceleration. Yeah, acceleration due to gravity is 10. That seems to be correct. Let's look at the rest. It falls with constant speed. Nope. As it's moving, as the ball is falling, as it's coming towards the ground, its speed increases. It falls with decreasing speed. Nope. Its speed increases. It falls with increasing acceleration. Nope. The acceleration due to gravity is 10 and it's constant, so the answer is A. (11) The graph shows how the distance traveled by a vehicle changes with time. Okay. Which row describes the speed of the vehicle in each section of the graph? Okay, let's look at this. This is distance, time. So meaning distance, time means that the gradient of this graph is going to give us velocity. This is all coming from the definition. We know that the rate of change of displacement gives us velocity. So distance divided by time gives us velocity, or it gives us speed. So here it is constant speed. And then here it's from Q to R, the gradient is 0. It means that this is 0 speed. That is what it means, that it has been moving this distance, then it reaches a certain point, and then it stops. But the time keeps moving. So here it is 0 speed. Then from R to S, this is still constant speed. So here they're asking us which row describes the speed of the vehicle in each section of the graph. So here, between P and Q, it is constant, yes. Then yes, it is 0. Yes, then between R and S, it is still constant, but in the opposite direction. So the answer is A. We are able to tell that the speed is either increasing or decreasing when we are dealing with a speed time graph. If it was a speed time graph, and so for example a speed time graph, that graph shows that the speed moved from 0 up to a certain point x, meaning that here the speed was increasing. But here in the distance time graph, we can only tell that the speed is either constant or not constant. So that is A. Question 11 is A. Question 12. The car is moving downhill along a road at a constant speed. Okay. Which graph is the speed time graph for the car? So a car is moving downhill along a road at a constant speed. So if it is moving down at a constant speed, first of all, here, this graph here shows that speed is increasing from 0 up to a certain level. So this is out. Even here, it shows that speed is starting from here and it is reducing. The question says a car is moving downhill along a road at a constant speed. So B and D are out. These ones are out. So when we come to these two, we have speed here. The speed here is constant. Even here the speed is constant, but here the speed is constant, but the speed is zero. It's constant at zero. The graph shows that it's at zero. So this simply, I mean, if the speed is zero, then how is the car able to move down the hill at zero speed? Zero speed literally means that the thing is stationary. So the right answer here is C, that shows that the speed is constant, and it's constant at a value above zero somewhere, a certain value. So the answer is C. Number 12. In a race, a car travels 60 times around a 3.6-kilometer track. This takes 2.4 hours. What's the average speed of the car? We know that average speed is equal to total distance, divide that by total time. So what's the total distance here? Well, a car travels 60 times around a 3.6-kilometer track. So it is 60 times 3.6. Divide that by the time it takes 2.4 hours. So the average speed of the car is going to become 90 kilometers per hour. And so our answer there is B. A tennis player hits a ball hard, and 0.4 seconds later, he hears the echo from the wall. So this is the tennis player, this is the wall. So it means that when he hits this ball, sound waves are going to travel, come, hit the wall, and afterwards they get back to his ear, like that. So those are the sound waves traveling from here, going and then coming back. Then they're saying the speed of the sound in air is that. So meaning that while these sound waves are traveling, they are traveling at a speed of 330 meters per second. And the tennis player hits the ball hard, and 0.4 seconds later hears the echo from the wall. Meaning that this sound wave, when it started from here, it traveled, hit the wall and came back. This means that the distance traveled is, we are going from here, move and back, and all that took a total time of 0.4 seconds. So the question is, how far away is the player from the wall? So they want us the distance. But remember this sound, by the time this person had this sound here, after 0.4 seconds, by the time he hears the sound 0.4 seconds later, the sound will have traveled from him to the wall and back. In other words, it will have traveled twice the distance he is from the wall. So let's first try and find the distance traveled by this sound wave. So we need to first find that distance. So we know that distance is given by speed times time. We know that the speed of the sound was 330. We multiply that by the time it takes for that sound wave to move to the wall and then come back to his ear, which is 0.4, and we shall end up with 132 meters. So it means they were 132 meters. But the question says, how far away is the player from the wall? And this sound wave, he is able to listen to it because it traveled twice that distance. In other words, it first went, hit the wall, the sound wave, then it came back to his ear. So this 132 meters is twice the distance from this young man and the wall. So what do? We divide this by 2 to get the distance the player is away from the ball. So the real distance here is going to be 132 meters. Divide that by 2. And when we divide that by 2, we shall end up with 66. So the answer here is A. That is how far the player is And then moving on to 15, an object moves initially with a constant speed and then with a constant acceleration. Which graph shows this motion? So we first constant speed, this is here. So constant speed is right there, then constant acceleration, meaning the gradient, because a speed time graph gives us acceleration. So here is constant acceleration, acceleration is constant. Here acceleration is 0. However, when acceleration is 0, the speed is constant. So constant speed with constant acceleration, B. And finally, a child is standing at a platform station. Yeah, a train traveling at 30 meters per second takes 3 seconds to pass the child. What's the length of the train? So that's like indirectly asking you distance. A train is traveling at 30 meters per second. So the speed is 30 meters per second. And the time taken for the train for its entire length to bypass the child is 3 seconds. So the length of the train, that's the distance, is speed times time. This is 30 meters per second, multiply that by the time, which is 3 seconds, which is 90 meters. The answer is D. Remember to share this with your colleagues. My name is Arnold Ranga Kuramia, and this is Kisembo Academy. Take care.